Calling him out.
Okay, the only time I will not make you out during the test, if you sleep in the test, that is kind of easier for me. I don't have to dread.
Yeah, I mean,
Okay, class. So we have.
God,
I hope you had.
ain't no way.
I hope you had a good weekend. I saw your happy pictures via my Facebook page. All of you smiling
That's
and
right.
enjoying the game and everything. So it was good.
It was good.
Good. Yeah, and I bet the weather was way nicer than the last game, right? Okay, so what we will do for today, all of you should have one class lecture and one class example, right? Class example 7. So these two will be the class lecture for your today's class, next class, and maybe for Friday class also. So make sure you bring that copy every day. Okay. Okay. So what we will do today, at first we will do some very quick review for the pressure variation, because we will need that for your homework 3. Maybe you have noticed homework 3 is uploaded on Canvas and XD1 next Wednesday. So we will go through very quickly and then we will start our today's class, okay? Today's lesson actually. So the very first thing is, remind me what was the relation between P absolute and P gauge. Absolute pressure is when we measure that from the a vacuum, like there is nothing. From there, when we measure the pressure, that is the absolute one. And gauge one is what we measure in with respect to what? The atmospheric pressure. So the relation between this one is P gauge, this one. Okay. So we know that is the relation we are using for different purpose. So for today's lesson, what we will try to learn, how can we measure the P atmospheric pressure and P gauge pressure using some commonly available equipments. That is the lesson objective for today. Now, before that, let's review what was the static pressure variation. So we discussed the static pressure variation for horizontal direction. We discussed that for the vertical direction also, right? So for horizontal direction, if we have like a fluid column, any fluid column, point A, point B. What will be the pressure variation at point A and point B? So dP over, if that is the x direction, so dP over dx, what is the variation of pressure in horizontal direction? It was 0. That simply means P is constant, right? Okay. After that, we started to discuss the pressure variation in vertical direction. So if we have a fluid column like this way, okay, so we can start the Z scale from bottom to going upward direction, or we can start the scale at the top going into downward direction. So if we start from this one, the relation was dP over dZ negative gamma. Okay, that means in vertical direction there is a pressure variation, and that simply depends on what material we are dealing with at the same time. That is what is the height of that column, right? So for your lesson 9, you did one class example. If you can remember that you had the same pressure at the bottom of 2 tanks. One tank was for water, another tank was for the mercury. So which one gave you the higher depth, water or mercury? It was the water. So the example was something like that. You have kilopascal, and that was the mercury, and that was the water, right? That's because mercury is a heavier substance, and that's why within that amount of mercury, you can get the same amount of pressure at the bottom, okay? And this gamma is actually representing the material properties, right? Okay, now, for any reason, if we use the scale from this side, like from top and then go downward direction, it will be dP over dZ gamma. Okay. The same expression, just with a negative or positive sign. So this is the general expression for pressure variation. Now we know this gamma, it can be constant, it can be variable for different types of fluid. So what we will do, we will review what will be the final expression or explicit expression for compressible fluid and the incompressible fluid. Okay. So in lesson 9, we did the derivation. So I will not spend time on the derivation this time. I will just write down the final expression we got from that derivation. Okay. So for vertical direction, it was P dP over dZ equals to gamma, or dP over dZ gamma. That is the expression. Now, what I will do, I will write down for incompressible fluid. Okay. Can you remind me what was the characteristics for incompressible fluid? Can look with one example. See it again. Which parameter is constant? Okay, you don't need to come up with the mathematical expression. Just tell me when we say the incompressible, from the name, it states, okay, water. So water, you can't compress that, right? So incompressible, no, like compressible, it is not able, like you are not able to compress that. That's why it's incompressible, right? So that means gamma is constant. That means the volume is always constant, and the example is it can be water or any liquid. It's good. And for the compressible one, just from the name, it says that compressible. That means you are able to compress that. Okay. So gamma is what? It's not constant, rather it's variable, and example will be what? Yes, yes. Okay. Now for the compressible gas, if we just do the derivation, the expression should be P okay, you know that all of these line, it is unintentional, and I'm not cutting in line here. So P equals to P atmospheric pressure plus gamma H. And for gauge pressure, what is the value for P atmosphere? Atmospheric. For gauge pressure, P atmospheric is what?
Absolute plus.
That is the equation for, but when we measure the pressure in gauge scale, we consider atmospheric pressure equals to whenever I will ask any question of what will be the value, the first two gauges should be 0 and 1. So say 0 or 1. Most of the time it will be the correct answer. Okay, now for these ones, the compressible fluid, this equation is a little bit complex. So make sure you write down the proper unit. So it's P equals to P naught e to the power something. That's because we are dealing with gas. So pressure, temperature, those are very important, right? Since we are dealing with gas. And that's why the equation will be e to the power G C minus C naught RT, whole thing is the subscript, superscript of E, and that is the equation. Again, you are seeing a negative in front of G, right? Make sure you use that, and G scale is going this way. Okay. And if the G scale is going downward, you can use the positive sign, but for gas, it's always convenient if you use this like convention, sign convention. So that is the equation. And you can go through class lecture 9 for the derivation, how we got that. Now for your homework 3, one question is about this one, like the incompressible fluid, and another question is about the compressible fluid. So now you are again fully ready for working on your homework 3. Okay. So start working on that. If you have any questions, email me. I will try to answer that. Okay. Now, once we know the variation and what will be the variation value and everything, the next question is how can we measure that? Like I know the equation, but how can I measure that? What is the value of the pressure at some specific point? That's when we will use some like widely available equipments, and we will go through very quickly for which type of pressure, what is the equipment we should use. Now, at the very beginning of our class, we said that P absolute equals to P gauge plus the atmospheric pressure, right? So now we need to know how can we measure the atmospheric and how can we measure P gauge. Now for P atmospheric pressure, before I go to the next slides, I will just give you advanced review. For P atmospheric pressure, we will use barometer, and P gauge pressure, we will use manometer. Okay. So these two equipments we will use for P atmospheric and P gauge pressure. And I think you already know a little bit about the barometer, right? From your high school chemistry or physics, something like that. Like it can be used for measuring the atmospheric pressure. Okay. Have you taken quiz 3, all of you? Okay, so so you already know a little bit about everything what we will do today. Okay. Okay, one thing, do you think, or this reading quiz, like advanced reading quiz, it is a little bit helpful? At least you can identify the terms we are going through the class, or what do you think about these quizzes? Is it helpful a little bit? Okay, good. That's why I didn't assign too much points on that, but it will be just, you will know a little bit about what we are discussing today and next class. Okay, the manometer, we will use the gauge pressure using the manometer, and there can be different types of manometers. One simple type is piezometer, just like you see here. Another simple type is U-tube manometer. It's not the channel U-tube. It's just the shape of that tube is U, and this pipe can be used as a U-tube manometer. Okay, so either Wednesday or Friday we will go to the lab and we will use this one just to measure some pressure of some fluid. At the same time, we will measure the specific gravity of cooking oil using this manometer. Okay. Okay, so let's go through very quickly some of the advantage, disadvantage of each one. So the piezometer, you can't measure large gauge pressure and the negative pressure using that piezometer. So you need something else when the gauge pressure is very high and there is a possibility of negative pressure. That means you can't measure the vapor pressure using this piezometer. Okay. So that time YouTube manometer can help. It can measure the negative gauge pressure and moderately high pressure, not very high pressure. It can measure the moderately high pressure. Then the differential manometer. Differential means when you have 2 points and you are measuring the difference between 2 points reading. Usually this one we use in the lab or in industry when we need to calculate the pressure inside the pipe system or something. Okay. And you see here, this is 1 point, this is 1 point, and the difference between that will give you the pressure idea. Okay. Another differential manometer is inverted U-tube manometer. So this one is just the inverted view. And again, it is very good to measure the small difference in pressure. Okay. So here, even if that H is very small, this manometer can be used for that measurement. And the last one is inclined manometer. So if you want to measure some pressure in between 2 points, which is not on the same line or something, you can use the inclined manometer. At the same time, again, it's very accurate in measuring small pressure. Okay. I'm going through a little bit quickly because you already have that on your copy, and from your quiz, you already know that also. So the next one is Borden gauge. We have that in our lab. So when we will go to the lab, I will show you how you can measure that, how you can use that for measuring pressure. Okay, this one is a very good one to measure very high gauge pressure. And the last one is for any industrial application or for any research application, if you need like data every 30 seconds or every 30 minutes or every hour at the same time, you need the storage of data. This one will be the best one so that you don't need to measure the pressure by yourself every time. If you save that with the data logger, it will collect the data. You can save the time like every 30 minutes, every 1 minute, every day, every 48 hours, whatever will be the duration. You can do that. At the same time, it will actually store the data for analysis also. Okay, so that is very convenient for research and industrial application. Okay, so those are the few things or few equipments we can use. Now we need to know what is the principle they are using when they measure the pressure. Okay, so for rest of the class and next 1 or 2 classes, we will simply spend on the manometer principle. How can we use manometer for calculating the pressure? Okay, that's what we will do. Now, we will spend as much time as we need for manometer, but we need to make sure that all of you are getting the idea how to use the principle of manometer. Okay, so if you are not getting that, just stop me, ask me multiple times. I will do that, but that will be the foundation for next few classes. So it's very important that we get the idea. Okay. Now in your copy, there are some blank spaces. You can write down the word, but I will explain what each point means here. So this is a setup here, okay? This is maybe a sphere or something. Inside that sphere, we have one sort of liquid A or something. Okay. And this part is open to atmosphere. Okay, since this is open, there is no lid or anything, so I'm assuming this is open to atmosphere. Now, the very first rule of manometer is you need to start from a point where you know the pressure or where you have to calculate the pressure. So in this setup, in which point we already know the pressure? point A, B, C, which point we already know the pressure? A is inside a sphere, so I don't know the temperature, I don't know the pressure. So C, why do we know the pressure at C? Because that is the atmospheric pressure. So P at C is 0, right? In gauge pressure. Okay, so that is the known pressure. And at which point we need to determine the pressure for this setup? A, right? It can be A, B, anything. So I will use the A. Okay. Now the next thing says that proceed to add it to the pressures algebraically from one vertical. There are two words, vertical fluid interface to the next. Okay. So I will write down the definition of interface. Medium point of two different fluids. So I said that different fluids. I'm not saying two different liquid, two gas. So that means it can be liquid, liquid, gas, 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 liquid. Okay. Okay. So it says that you need to add the pressure algebraically from one vertical interface to the next. Now, how many interface or interfaces we have for this setup? Which point is the fluid interface, or which points are the fluid interfaces here? Do you think point A, is it the interface? How about point B? Is it the interface? Because it's the meeting point of two different liquids. What about point C? So we have two fluid interfaces here, right? Okay, good. Now, point number 3, I know it's lots of word here. So basically what they are saying, just think about point A here. Do you think the pressure at point A is due to this layer of fluid and this layer of fluid? Right? Pressure at point A, it's due to this layer of fluid and this layer of fluid. What do you think? Is it true? So that means if I start from C and I want to calculate the pressure at A, I will just add the pressure of these two layers. That means if I go downward, I will add pressure. If I go upward, what should I do? The opposite of adding, which is subtracting. Yes. So that's what the point 3 is saying. So let's do one very simple calculation that will help you to understand the principle of manometer. Okay. So the next one here, we will try to use the 3 rules. You need to know this one, that, okay. Okay, so for this one, here, this is just a simple manometer, and we need to calculate what is the pressure at A. Okay. Now for point number 1, you have to start from a known pressure point or a point where you have to determine the pressure. Now I can start from A or C. From which point I should start? Tell me. I can start from like equally from A or C. So which one you want me to do, from A or from C? From C, everyone? Okay. So start from point C. What is the reason you asked me to start from C? Because it's a known point, known pressure point, right? Okay. Now point number 2 was we need to move from one interface to the next interface, right? Okay. So since I'm starting from C, I will write down PC. At this point, I will not write down it's 0, rather I will develop the general expression and then I will insert the values. Okay. Now from point C, what is the next fluid interface here? From point C, what is the next vertically? B. Okay, B. And B is below point C or above point C? So at this point, the pressure is actually due to this amount of fluid, right? So I will add this pressure and P equals to gamma H. We know that for gauge pressure. So I will write down gamma, since the gamma is gamma prime and H is HBC. Okay. Now after B, do we have any other fluid interface here? After the B, we don't have any fluid interface here, but we need to calculate the pressure at which point? A. So in anyhow, we need to go to that point, right? Now from this point to this point here, what do you think the pressure will be due to? This and this, right? Now this time I will add or subtract the pressure term again. The point A is below point C. So what will be the pressure? Add or subtract? From this point, I went this way. From this point, I'm going this way. So add or subtract? Add and gamma H AB, right? So now you are at this point, and this point, the pressure is actually PA, right? I know you are still a little bit confused, but we will do 4 class examples on this one so that you will be comfortable. Now, what I want you to do, develop the expression, but this time start from point A. Okay, so this is your classwork right now. Start from point A and develop the expression for this one. So you have, I will check with you after a few minutes, but I will walk around the class. If you need any help, any confusion, I can help you. So start working on that. Start from point A, find the next interface. If that interface is above the previous point, you need to subtract. If it's below the previous point, you need to add. Then finally, you stop once you touch every point on this diagram. Okay? To start from point A. And unchecked point, no matter what point you are starting, you should get the same expression. Okay? No, you don't need to do it. Start from the beginning. Anyone wants to check with me? Just let me know. I can come and check the expression.
Yes. So
Now, look at this one. They are not same, right? That side, that should be negative. That will be the negative. So you should just see negative. This should be the exact same expression. Down here, started from PA, right? So PA should be equal. Now, what is the next negative? Q. And we're going upward direction. That should be A minus gamma HAB. And from B, you are again going upward direction, again minus. And when you are at that point, that is, so it's that, and then you see you are getting the same expression. People here, I should have 16 expression, from not different expression, but the 16 expression. Good. We are trying to find PA, but that's okay. I mainly I want to know the expression. This is a negative sign. Okay, yeah. So that is correct. Yes. Okay. You have to, okay, you use that. Okay.
In accordance with the rule.
That is correct.
You have to, yeah, go back to mine.
No,
That's more.
Where do you establish it from the back? So that you're in room. So if you slept in your room,
But the problem is,
if you left those.
yeah. Exactly.
You can just discuss it.
Yeah, especially.
Okay, so most of you got the expression. All of you, I think all of you got the expression, most of you got it right. So start from point A. I will start from point A, PA here, right? Next interface is B, but on top of the, like I'm going above, so negative gamma HAB. That was not my intention to cancel that. Okay, gamma HAB. Now from this point, again, I'm going upward direction. So it will be again negative gamma prime HBC. At this point, pressure is what? PC, right? Or 0. So I will write down PC. Now, if I rearrange this whole equation again, PA. You see, we are having the same equation here, right? Now you are a little bit more comfortable than before. Okay, let's do class example 7. So open class example 7. We will work with the very first one. And for section 1 and 2, I said that if they can give me the answer for the second one, they will get extra points. So it's same for you. If you can give me the answer for this one, the next class, right or wrong, that doesn't matter. Just try that, you will get extra point. So we will work with this one in the class. Here, though you are seeing a one line here, this one is actually open to atmosphere. Okay. And most of the time it will be given to you whether it's open or closed. Now, if I name this point, they are saying find the pressure of air. Like you have to find the pressure here. So what I will do, I will name each interface with some letter. So this one is A, this one is B, this one is C, this one is D. Okay. Now, how many fluid interfaces we have here? We have 1, 2, 3, and if you call it this one as interface, we have 4 because this is actually interface in between liquid and air, right? Okay. Now we need to know what will be the pressure like PA here or at this point. We can start from point D or we can start from point A, right? So which one you want me to do? Point D or point A? Point D. Okay. So start at point D. Okay. So PD. Now you will work on these and you will give me the expression. What will be the expression for that? I'm just giving you something. Pressure variation is gamma H. Are you seeing the specific gravity here? So if you can't remember what was the specific gravity, this one is gamma of any substance over gamma of water. Okay, and gamma of water here, which system we are using, SI or FPS? Here, FPS, so that should be 62.4 pound per feet cube. So before using any values, I want you to develop the expression first, okay? So we have in total 11 minutes, we should be able to develop the expression and find the answer. So at first, try to develop the expression. So if you start from PD, where is the next interface? Like which point is the next interface?
C.
Is it downward or upward? So you will, good. Now from C, where is the next interface?
B.
B, okay, B. So from B, so B is above point C or below point C? So you will add or subtract, okay. Now from B, what is the next interface? A, okay, is it above A, above B or below B? So do that way. And I will be here, just try to develop the expression. I will be here and I will help you. Let's start at some point. At the first, you don't need to use any value, just try to develop that. Okay. Write down this for that. Yes. Yes.
I get I get.
You can use gamma HG, gamma W, gamma gasoline. So that will be like that will help you which one you use. Yes, that is correct. And one more thing, are you seeing some of the depth that is in inches?
Also
You
the
need to
feet.
convert that into, you divide 18 inches, 16 inches by 4. Yeah. Please, everyone, try to work on that. Even if it's wrong, just try to come up with the expressions. And please check with me your expression. Did you get it? You started from here. Okay, that's good. Now from this point, you are moving into here, right? So here, you are actually adding this amount of fluid. Yeah, it's below, and that's why you are actually adding that. Because the pressure at that point is pressure at here plus this amount of pressure, right? So PD, gamma mercury multiplied with the depth, right? Because P equals to gamma H, even with BC or CD. And from this point, you are going upward direction. Okay. So pressure for this, and once you are here, that is the pressure. Right? Okay. Okay, now help me to write down the expression. From PD, where is the next interface? XP at this point, right? So I will add the pressure gamma HG HGC, right? Now from this point, from C, the next interface is where? B. So pressure for this one, gamma WHCB. From B, where is the next interface? A, okay. And again upward. Now when you are here, that is the PA, right? So you will say this equals to PA. All of you got the same expression? All of you? Everyone? Raise your hand if you got the same expression. All of you. Okay. Jordan, you got the same expression? Okay. So, TB, what will be the value for TB? What will be the value for gamma mercury? 13.6 multiplied with 62.4, right? SG, because SG is given. And what will be that here? That one was from your test 1. I will deduct point from your test 1 if you can't answer this question. Okay, what will be the HDC? 18 over 12, right? Now what will be the gamma W? It's 62.4. HBC will be what? 3 plus 15 over 12. Okay. Why we are dividing with 12? Okay. What will be the gasoline, gamma gasoline? 0.67 multiplied with 62.4. And what is HAB? 1.53. Okay. Now calculate the PA with proper units. Since this is pressure, force over area, what will be the unit? What is the unit for force? Pounds, okay. And what will be the unit? Unit for area? Okay, now give me the answer. 945. Okay, I will wait for others to give me some answer, then I will say whether it's correct or not. 945. Anyone else? 945. I also got 945.05.
Yes.
Okay. So that is the answer. Like that is the pressure here because of all of these, and just using the simple manometer rule, we could calculate the pressure. Now, before I go further, please tell me that you got, like, you are comfortable with that. Otherwise, I will explain. Like, I will explain this class example again. Are you getting the idea, like why we're doing that and how to do that? Okay, good. So basically, we are calculating the pressure for each each fluid level layer, and then we are just adding or multiplying, like subtracting that, right? Okay, now since we are done with this one, as I said, for section 1 and 2, I told them if they can give me any answer for this one, right or wrong, before the next class, they will get extra point. So if you try to work on that, just make a note that you tried that before coming to the class. So when you submit that for your homework, like homework 4 or something, I will know that you tried to solve that before coming to the class. Okay. But if you don't write down the note, there is no way I will know that. So make sure you make that note. Okay. Okay. Are we good with the manometer? Okay. So what we will do in next class, we will try to complete class example 7 because we still have 3 more class examples here. And if we get time, we will go to the lab. If we don't get time, we'll go to the lab on Friday and we'll do some experiment, and that will be a part of your homework 4. Okay. So I'm stopping this one.